Hi guys, BuildZoid here, and we're back with another DDR5 overclock on the 9800X3D. This time we're taking a look at DDR5-8000 CL30. So yeah, anyway, the motherboard that I'm using is an MSI X870 Tomahawk, which was provided by MSI, so big thank you to them for sending over the motherboard for testing. The memory kit is a G.skill TridentZ5 Neo RGB 2x16GB 6000 CL26 kit. Which was provided by G.skill, so a huge thank you to them for sending over this memory, because I am relatively certain that on any other memory kit, at least any other memory kit I own, this wouldn't be possible. As the 6000 CL26 Expo kits from G.skill, they're binned for 6000 CL26 at 1.4 volts, which is insane. Like, that is the tightest cast latency bin of Hynix 16 gigabit ADI that you can currently get. So yeah, big thank you to G.skill for the memory. Like I mentioned, it is based on Hynix 16 gigabit ADI in a single rank configuration. And as you can see, I do have a fan pointed directly at the memory sticks, which is held in place like so. So I just have these very tall motherboard standoffs to hold the fan in place. Yeah, so let's take a look at what I have in the OS over here in terms of stress tests and all that. Now, this took a while to set up, mostly because one of the things that I was trying to do with this, other than just smashing the cast latency through the floor, was also, testing out new TRC limits because of that recent video that I did about how TRAS and TRC on AM5 actually work very weirdly, as in they don't follow the JDEC specification basically at all. But anyway, so what I ended up at is 8000 CL30 tier. Well, you can read the timings yourself. The voltage we're at is 1.75 volts. Or actually, not 1.75, 1.77. I originally started with 1.75, but I was running into some stability issues. I think ultimately they were just TRC, so I probably could have gone back down to 1.75 once I raised the TRC to 62. But 1.77 and 1.775, I mean 1.7, yeah, are basically the same voltage as far as I'm concerned. The memory sticks do get pretty warm at this point. I mean, we are on a 9800X3D, so, it doesn't actually have that much memory bandwidth. It can't really stress the memory sticks that much. Like, one of the things I kind of want to do is try a similar setup with, like, an Intel CPU that works at 8000, because I don't have one that works at 8000, but because I do wonder, like, if these settings, like, on an Intel chip, I think this would run at, like, 60 degrees, is basically what I'm thinking. Whereas on a 9800X3D, the memory runs a lot cooler because you simply cannot read or write that much data from the memory with a Ryzen CPU because the Infinity Fabric is a massive bandwidth bottleneck. But anyway, so even though we're running like really high voltages, the actual memory temperatures aren't that high. That's partially because of the fan and partially because of the bandwidth limitation of Ryzen CPUs. But anyway, so yeah, so from like a thermal perspective, I'm not too concerned about it. Honestly, I don't think the memory voltage would even damage the memory sticks. Like, I've not heard of anybody managing to degrade ADI yet, other than, like, I've heard somebody apparently doing tests at, like, very high operating temperatures with high voltages, and then you start running into problems, but by very high temperatures, I mean, like, north of 75 degrees Celsius. So, yeah, that's, very far away from the temperatures we're running here. Anyway, no errors in hardware info. I ran Prime 95 for almost 24 hours. I'm kind of annoyed that I stopped it a little bit early, because it would have been kind of cool to have that full 24 hours. And the reason I ran it this long is just because of the, like, stability problems that I was running into with TRC. We also have the 24 hours of Karhu, and I also ran 6 hours of Y-Cruncher because, yeah, like this setup is, like, at 1.77 volts, this is high enough VDD that I honestly expected to run into just the stability getting worse as the voltage gets higher, because that is a thing on some memory kits, is if you keep raising the VDD voltage, Instead of the stability getting better, at some point it just rolls over and it just goes downhill. So I am honestly also really surprised that this even like that this works. Yeah, I am quite surprised by that. Because I thought like 1.75, I was like, okay, that might stabilize, but 1.77 does not seem reasonable at all in terms of like, hey, this actually passes stress tests, but it does. So that's cool. Anyway, the thing I wanted to show you is some of the TRC stuff. So here we have one of the early tests, and this is super annoying about TRC, right? So you can see I have 16 hours of Prime 95, no errors, and this is with TRC 48, also 30, 45, 38, 48, right? So basically the same primary timings. I wasn't really changing anything else. I did bump RTP to 16 because when you're running low TRP, that can sometimes be a issue. But anyway, yeah, so I ran this, and you know, it passed Prime 95, it passed Y Cruncher, and I'm like, oh, cool, this is just, you know, easy video. This was like a week ago. Though admittedly, I've been like, once this actually passed, I've been kind of procrastinating on recording the video, as you can tell from the 171 hours of uptime that the system has. But it was stress testing for 2 days, and then it was sitting idle for the rest of that. But anyway, so yeah, I thought like, oh, easy video, and then 5 hours into Karhu, 1 error. Okay, that's not fun. So let's pull up the next screenshot. So then I'm like, okay, maybe CL30 is just too tight. So I loosen out to CL32. I lower VDD to 1.65 because you shouldn't need that much VDD for CL32 on these memory sticks. This is probably still higher than it needs to be. But anyway, so yeah, I go, you know, CL32, 1.65. 4.5 hours later, Karhu errors out again. Also, I have RTP at 12 this time. So, you know, got pretty annoyed by that. So, yeah. And then ultimately what I settled on is the settings that we have here, where even more voltage, much looser TRC. I did also run like a test of TRC at 56. That also errored out. Which is actually the reason I ended up running such an insanely long, like, Karhu and Prime 95 is because that, like, second TRC, like, at 56, the TRC errors were even later into the test. So that's something to sort of keep in mind, is if you're tightening TRC a lot, like, you're running it really very, like, I don't exactly have, like, exact numbers on what constitutes extremely low TRC yet, but I think for like 6,000-ish, it'll probably be below 40. If you're like trying to push it below 40 at around DDR5-6000 to like 6400, I think that would be very tight. And at 8,000, I think below 60 is probably pushing the limits. But anyway, so yeah, one of the like 56 just took forever to error out, and then I'm like, okay, well, let's just go with 62 and even more memory voltage, and at this point, like, I think this is stable. Like, the thing that's kind of, I guess, funny to me is, like, some people might consider, because, like, this is why I don't think, like, running memory stress tests for less than, like, 6 hours or something, like, that's just not valid, as far as I'm concerned. Like, if you run a memory stress test for an hour, then, like, I don't think that's a good way of doing any kind of memory stress testing, because like it was running fine. It's not like the memory temperatures are high or anything, right? They're lower because the lower memory voltage, and it still errors out. So yeah. So if you're going to be pushing TRC, definitely, you know, like if you're going to be trying to push TRC down, definitely run your memory stress test for like a significant amount of time. Don't just run it for an hour because it might not catch any instability. So anyway, I think that's everything I wanted to show in the OS over here, because yeah, like there's like this is stable, right? Prime 95 for basically a day, more than a day of Karhu, 6 hours Y Cruncher, no errors anywhere. So cool. Just needs a lot of voltage, and that's kind of that. But honestly, I like it's crazy to me that CL30 at 8000 can work to this degree of stability. Again, I do think it would be really interesting to test this with a CPU that isn't massively memory bandwidth starved, but I don't have any Intel CPUs that like work at DDR5 8000 at all, right? So I'm not going to put this memory kit on like a 14th gen and try to run something like this because I can't even run 8000 on a 14th gen in general. Like, I've never been successful with that. So, I don't know. I'm thinking, like, maybe I'll try get an Arrow Lake CPU for this, because Arrow Lake's memory controller at 8000 should be relatively reliable. But anyway, let's go take a look inside. Oh, wait. Just going to make sure I have a screenshot of this, and then we're going to go... oh, also the 9800X3D was just running the default power limits, because the 9800X3D, unlike the 9700X, is not power starved. So anyway, let's go take a look in the BIOS. Oh, I forgot to show the PHY RDLs. We could do that later, I guess. They should be matched. You know, stuff like situations like this make me think, you know, maybe I should have some kind of like list of notes of like, hey, this is what I should show when I'm in the OS. But knowing myself, I would just forget to read the notes instead. Instead of forgetting to go over it, I would just forget the notes. So, anyway, so here we are in the BIOS, and in terms of voltages, like SoC voltage is nice and reasonable because we're not, you know, pushing the memory controller frequency super high, right? We're at 8000 in 2-to-1 mode, so the memory controller is only running at 2 gigahertz. So we don't need a lot of SoC voltage, so stock SoC voltage it is. Then, oh, it's actually 1.76. Okay, so that's, I mean, that's kind of the same thing as far as I'm concerned. This is one thing that really annoys me with, actually, it's not that annoying, but the voltage sensors on DDR5 memory sticks are horribly inaccurate, and that's when they work correctly. But sometimes, like, you'll get, like, sensor glitches where, like, I have memory sticks where you set them to 1.65 and they will randomly report 1.3 volts. That's also really fun, but that's just like the sensors are just not that accurate. The voltage regulator is actually pretty accurate, but the sensors for the voltage regulator that you can access in software, garbage. So anyway, 1.76, 1.45 for VDDQ, 1.45 for VDDIO. A reason why the VDDQ and VDDIO are so low is these are, well, so VDDIO is for the CPU. As you can see from the name, but VDDQ is just the signaling, is the power supply for the signaling circuitry on the memory chips. So basically, VDD allows us to like move data from the internal memory banks to the signaling circuitry quickly. That's why we can why if you want to run really low CAS latency, you need such insane amounts of VDD voltage. But then, as far as actually transmitting the data to the memory controller, like the signaling circuitry, if you're running DDR5-8000, regardless of the CAS latency, it's not gonna, like, the voltage requirements aren't really gonna change. And so with this motherboard, I generally just use 1.45 volts VDDQ at DDR5-8000 because that has worked for me. Also, where's the BIOS version? Oh, if you're wondering about the BIOS version, you can see that over here. We're on 1A20. But yeah, so for DDR5-8000 with this board, I just use 1.45 for VDDQ and VDDIO. And if you're just pushing CAS latency into the ground, you don't really need to change that. You just need to change DRAM VDD. So that's at 1.76. I don't think I changed anything else. Yeah, I didn't need to change anything else in terms of voltages. I believe VDDP, yeah, VDDP's on auto. This motherboard does a good job of setting it on its own, and the same for VDDG voltage. It's not like we're pushing some crazy FCLKs, so messing with the VDDGs isn't really necessary. Anyway, UCLK is, of course, equal to MCLK/2. And then here are the timings. So CL30, pushing low TRC DWR. Well, I haven't tested less than 16, so I don't know if that could work. But 16 is already a big performance improvement over running TRC DWR at the same value as TRC DRD. Well, in scenarios where TRC DWR actually matters for performance, which isn't every scenario because write operations aren't usually a bottleneck. Anyway, so TRC DRD at 45, this is basically as low as it's going to get at DDR5-8000. And while the G.skill has done a lot in terms of binning these memory sticks for cast latency, in terms of TRCD, they're not really any different from any other Hynix memory kits that I have. So, yeah. Anyway, TRP at 38, which is about the limit for what you can run TRP at DDR5-8000. TRAS 126 because it doesn't do anything, so we can set it as high as possible, and there's no negative there's no downsides to it, and it can help. And well, if you set TRAS too low, you might run into some stability issues. If you set it too high, it's not like you lose any performance. So there's no reason to actually set it to anything other than the register limit, which is 126. Then TRC is at 62. I'm pretty sure this is about as low as it's going to go for this setup. So, yeah, because like I mentioned, I was having stability issues even at 56. Though, funnily enough, even 48 boots, right? So it's like there's a lot of room for setting TRC way too low to be stable. And yet the system will still kind of function. TWR at 48, which is as low as that goes. TRFC at 480. This could maybe go a little bit lower, but when your refresh interval is set to 65,000, it's not really going to make any difference to performance. Which I guess I should point out that like CL30 at DDR5-8000 is more about looking cool in screenshots than it is about actually affecting real-world performance in any human perceivable way. There are benchmarks that can measure the benefits of CL30. There are no humans that can experience the benefits of CL30. Because humans are just very slow compared to computers. So anyway, here we have RTP at 16. Which is just because of the TRP that I'm running. Though on some kits you can get away with like low TRP and low RTP, but yeah, I didn't want to deal with that on this setup. So it might have worked at 12, but considering how much time I was spending trying to fix the TRC errors, I don't feel like finding out if TRP is going to be upset or not. Then we have TRRDL at 8, TRRDS at 8, because there's no point, like in 2-to-1 mode, these don't actually, like you can try to set them lower, it just doesn't do anything. TFAW at 32, same thing. Since these two can't go below 8, there's no point setting TFAW below 32. WTRLs, I have 16 and 4, which is about as low as they're going to get. And then for the tertiary timings, 8-1, 8-1, and then 416. And then like SD and DD timings are set to auto because this is a single rank setup, and so SD and DD are not relevant to the memory sticks that we're running here. And the memory controller doesn't use them. And I should have my, so I do have my read pointer initial value set to 1. So that's just to get the PHY RDLs to match up. Depending on your CPU and memory sticks, the value, the number you need to get them to match might be 1, it might be 2. It depends. For this setup, it's 1, and I believe it's matched at 38 on both sticks. But we'll go check that before I end the video. And other than that, I also did adjust the nitro settings a bit. So if we go over here, DDR options, you can see I have the nitro settings set to 131, which is basically the limit of what you can run at DDR5-8000. On auto, this would actually run like 231, which is a bit slower. Yeah, so this is just like one of those, like, if you're going to be pushing your cast latency to 30, you may as well set your nitro timings. Though, again, I'm going to point out, like, on auto, the auto is 231. So this really, like I set all 3 of them just for like sake of knowing for sure what they're set to, but on auto it should be 231. So 131 is barely like a difference from the auto settings. But anyway, so that's, I believe, it in terms of BIOS settings. Because yeah, this there's not really there wasn't really much that I had to do here. In terms of like mainly it was figuring out, how much DRAM voltage this needs to function, and then not setting the TRC so low that it errors out eventually. Because that was like the main issue I was struggling with is like I started with a TRC of 48 and that worked great. for a while, but it wasn't actually fully stable. So anyway, let's go back into Windows, and I'll just show you the FiRDLs. Luckily, we won't have to retrain, because we're just exiting out of the BIOS. Man, why do I use the absolute cheapest SSDs for my test benches? Are you kidding me? Why are you still... Anyway, where's Zen timings? So, yeah. So here we are, and you can see FiRDL 38, and then if we switch to the other channel, 38. And that's because of the read pointer initial value being set to 1. Because on 2 it wouldn't match up. Though on some memory sticks and some CPUs it might match up if you set it to 2. It's kind of like, it's not super consistent, you have to experiment with it. By default, as soon as you go to DDR5-6400, that defaults to 3. So it starts at, like, basically once you're at DDR5-6400 or higher, by default it's 3, and then you can try like 2. If it doesn't match, you can try 1. If it still doesn't match, you can try 0. And if it still doesn't match, you should give up. So, yeah. Anyway, that's it for the video. So yeah, G.skill makes some, or bins some, absolutely crazy Hynix A die. Like, yeah, like we're doing like a lot, like a normal Expo kit is like 6000 CL30, right? We're doing CL30 at DDR5-8000, so that is crazy. And honestly, I am surprised that this works with as much voltage as I'm running into it. Because I really, like, above 1.7 volts, a lot of the time, like, the stability doesn't necessarily keep, like, improving. So, yeah, I am, yeah, like, I am just generally very, very surprised that this works. And, that's cool, I guess. Like, again, it's worth noting that, like, the cast latency, it doesn't really make that much of a performance difference. So, to me, this really is more about, like, it looks really cool in screenshots than it is about, like, oh, yeah, this massively improves performance in a, like, perceivable way. Because it doesn't. It does, you know, like, it is faster in, like, various memory benchmarks. But, yeah, as far as, like, if you're playing games or something, is this going to make a noticeable difference? No. It's not going to be significantly faster than, like, CL34. And also, I guess the thing that I should point out is that all of the other timings, like, they just don't have that much variance to them, right? Like, TRC-DRD45, you can run that on most Hynix 8i kits. TRP38, you can run that on most 8i kits. The TRAS is literally as high as it goes, so that doesn't make a difference. The TRRDs, I use these TRRDs on basically every kit of 8i that I've ever run at DDR5-8000. WTRs, I use these on basically every kit of 8i. TWR48, same thing. TRFC480, same thing. SCLs at 8.8, same thing, right? So really, like, I'm super impressed that G.skill managed to, like, bin Hynix 8i into being capable of running 8000 CL30, but it is really just 8000 CL30, because all of the other timings are basically the same as any other Hynix 8i kit. So, to me, these, like, uber low latency, like, uber low cast latency, because the thing is, all the other timings, they don't change. It really is just, like, cast latency. That's, like, super low. So, yeah, these, like, uber low cast latency kits from G.skill are very cool from, like, a memory overclocking enthusiast perspective, because you're just not going to get memory kits that do cast latency this low otherwise. But cast latency doesn't matter that much in terms of performance, and all of the other timings are basically the same. So, you know, very cool memory. But not practical. And the way I'm running it here with this like extreme amount of voltage, impressive, not very practical in my opinion. Like again, you know, if I was running this at like 1.45 or 1.5, maybe 1.6 volts, this would, at 1.45, this would probably do CL34, right? Which is insanely tight for DDR5-8000 compared to most Hynix 8i kits. And it wouldn't need a ton of voltage. It would probably still require the fan though. Actually, not me. Well, it depends. Like, it depends. Like, I'm obviously on an open air test bench, so I might be able to get away without the fan. But if you're in a case and you have a hot GPU, then you're probably gonna want a fan. But yeah, like CL34, at least in terms of gaming performance, is gonna be basically the same. And it wouldn't need this much freaking voltage. So, it's still really cool memory sticks though. Like, yeah. But definitely for people who like memory overclocking a little bit too much, rather than, you know, you should get this because it gets the best real world performance. It is technically faster. I wouldn't say it's perceivably faster. So, anyway, that's it for the video. Big thank you to G.skill for these memory sticks because they are crazy. And thank you to MSI for the motherboard. Thank you for watching. If you'd like to support the channel, there are links in the description that you could check out. That would be very much appreciated. And wait, did I actually do the FiRDL thing? Oh yeah, I did. Okay. So yeah, that would be very much appreciated if you check out the links in the description. And that's it for the video. So thanks for watching and goodbye.